Good morning, students. Most welcome in chemistry class. Today we are present with the chapter Classification of Elements and Periodicity in the Properties. I am sure, students, you have learned this chapter in Standard 10. So, I think you have the basic concept. Let's recall and revise what we have learned. Different law. First law of triads. I want to recall what this law. According to law of triads, elements were placed in a group of three and they were called triads. Tri means three. These were placed in the increasing order of atomic masses. As for example, if you know, if we take the three elements lithium, sodium and potassium. Lithium atomic mass 6.9, sodium 23 and potassium 39. So the atomic mass of sodium, that is the atomic mass of the middle element, is sum of the atomic mass of first and third element divided by 2, that is 7 plus 39 divided by 2. Then we will get 23, and 23 is the atomic mass of sodium. This is the law of triads. Now students, Newland's law of octaves. The elements were placed in increasing order of their atomic weights, and it was noted that every eighth element had properties similar to the first element. The relationship was just like every eighth note that resembles the first in octaves of music. Sa, re, ga, ma, pa, dha, ni, sha. Newland's law of octaves seemed to be true to elements only up to calcium. Here, Daubernier's triad, lithium, calcium, chlorine, lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine, we can explain using the law of triads. And Newland's octaves, that is hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So, first and eighth elements, there are the properties, and these are similar properties, my dear students. Now, students, in your syllabus, Mendeleev's periodic law, we will start the Mendeleev's periodic law in Standard 11. In Standard 10, we have learned the Daubernier's triad and the Newland's law of octaves. But in your chapters, Mendeleev's periodic law. What is the statement of Mendeleev's periodic law? And this law is very much important for your exam students. Frequently, this question is coming. State the Mendeleev's periodic law. So, the law states that the properties of the elements are a periodic function of their atomic weight, and periodic means repetition of the properties of the atoms of the elements after a certain gap of their atomic number. Mendeleev arranged elements in horizontal rows and vertical columns of a table in order of their increasing atomic weight, students, in such a way that the elements with similar properties occupied the same vertical column or group, my dear children. So, what are the questions on the Mendeleev periodic law? State the Mendeleev periodic law, and the elements were arranged in the vertical column and horizontal rows. Vertical column known as the group and horizontal rows is known as the period. Mendeleev's left gaps under silicon and aluminium, and those were known as eka aluminium and eka silicon. Later, it was discovered that eka aluminium had properties similar to gallium, and eka silicon had properties similar to germanium. According to modern periodic law students, the physical and chemical properties of the elements are periodic function of their atomic number, not atomic weight. Mendeleev periodic table states that the physical and chemical properties of the elements are periodic function of their atomic weight. But modern periodic table states that the physical and chemical properties of the elements are periodic function of their atomic number. My dear students, modern form of periodic table was discovered by Henry Moseley, and hence it was also called Henry Moseley's periodic table. So students, who discovered the modern periodic law? Answer is Henry Moseley. Henry Moseley. The periodic law revealed important analogies among the 94 naturally occurring elements. Neptunium and plutonium, like actinium and protoactinium, are also found in pitch blende and ore of aluminium. The horizontal rows of the periodic table are called periods, with the vertical columns are called group or families. So just you see here, group and periods. Group and periods. Group means vertical and periods means horizontal. This horizontal rows is known as the period and vertical rows known as the group. Now division of periodic table. Very important students. The periodic table is divided into 4 blocks, mainly the S block, P block, D block and A block. Students, you know in chapter 2, structure of atoms, S block elements, P block elements, D block elements and A block. S orbital, P orbital, D orbital and A orbital. S orbital capacity 2 electrons, P orbital 6 electrons, D orbital 10 electrons and F orbital 14 electrons capacity to hold the electrons. S blocks. Now, I am discussing students S block elements. In S block elements, there are 2 categories elements. One is the alkali metals. The element of group 1s known as alkali metals, that is lithium, sodium, potassium, rubidium, cesium, francium, and group 2 alkaline earth metals, which have NS1 and NS2 outermost electronic configuration. Alkali metals, that is group 1, has the NH1 configuration and group 2 has the NS2 electronic configuration. They are all reactive metals with low ionization enthalpies. Students, later we will discuss what is ionization enthalpies. It is the energy that is required to release the electron from the outermost cell. They lose the outermost electron readily to form +1 ion in the case of alkali metals and +2 ions for the alkaline earth metals. The metallic character. Students, S block elements. S block elements means alkali metals and alkaline earth metals. Group 2 elements are alkali metals and group 1 elements are known as the alkali metals and group 2 elements are known as the alkaline earth metals. They are very much reactive metal because they have low ionization enthalpies. Next, the metallic character and the reactivity increases as we go down the group. Because of high reactivity, they are never found pure in nature. One question arises here, students, why the metallic character reactivity increases as you go down the group. Why? Because their low ionization enthalpy size gradually increases from top to bottom. Ionization enthalpy decreases, so their reactivity increases. Reactivity increases. Now students, the compounds of the S block elements, with the exception of those of the lithium and beryllium, are predominantly ionic. Now, what is the electronic configuration, general electronic configuration of S block elements? Your answer, students, NS1 for the alkali metals and NS2 for the alkaline earth metals. Now I am coming the P block elements. P block elements includes the group 13 to group 18. 13, that is carbon family. Students, P block elements comprise those belonging to group 13 to 18. That is group 13 boron family, group 14 carbon family, group 15 nitrogen family, group 16 oxygen family, group 17 fluorine family, and group 18 inert gas family. And these together with the S block elements are called the representative elements. Representative elements, my dear students, or main group elements. Leftmost portion of the periodic table, there belongs the S block elements, and rightmost portion of the periodic table, their P block elements are present, my dear students. What is the electronic configuration of the P block elements? NS2, NP1, 2, NS2, NP6. NS2, NP6 configuration, that inert gas contains the NS2, NP6 configuration. All the orbitals in the valence shell of the noble gases are completely filled. What are noble gases? Noble gases means the inert gases. Why they are known as the inert gases? Because they don't react to others, because their valence shell is completely filled by having the 2 or 8 electrons. Now, the noble gases thus exhibit very low chemical reactivity. Preceding the noble gas family are two chemically important group of nonmetals. They are the halogen, group 17, and chalcogens, group 16. Halogen family, that is fluorine, chlorine, bromine, iodine, astatine, and group 16, that is oxygen family members. These two groups, that is group 16 and group 17, have high negative electron gain enthalpies and readily add 1 or 2 electrons respectively to attain the stable noble gas configuration. The non-metallic character increases as you move from left to right across the periodic table, and metallic character, students, increases as you go down the group. Now, D block. Elements in which the d orbitals are completely filled are called the d block elements. And general electronic configuration, that is n-1 d 1 to 10 and ns 1 to 2. And properties, very much important thing, students. Explain the properties of the d block elements. D block elements, that is, there are 3 rows of d block elements: 3d series, 4d series, and 5d series. In 3d series, 10 elements, 4d series, 10 elements, 5d series, 10 elements. We have to study in standard 12 the 3d series, that is scandium to zinc. Now, in your syllabus, we have to study the properties and general electronic configuration of d block elements. My dear children, properties shows catalytic properties. Next, from colored ions. That is, they form the colored ions due to presence of unpaired electrons. Shows paramagnetic properties because in the presence of the incomplete d orbitals and presence of the unpaired electrons. From complex compound, it is also the reason of incomplete d orbitals and presence of unpaired electrons. They are often referred to as transition metals. Why? Why they are known as the transition metal, students? As they are placed between metal, that is S block elements, and non-metals, P block elements, and also due to their characteristics features, like as they are paramagnetic, they form the colored ions, they form the complex. These properties are included in the D block elements, my dear children. And last is the A block. Elements in which the A orbital is completely filled are called the P block elements. And general electronic configuration, that is N minus 2, NS2, N minus 1, D, 0 to 1, and N minus 2, F, 1 to. So, what are A block elements? Elements in which the A orbital is completely filled are called the A block elements. In your chapters, in your syllabus, only we have to know the electronic configuration of the A block elements, and in detail we have to study in standard 12. So students, what are the electronic configuration of the S block elements? That is N minus 2 F 1 to 14, N minus 1 D 0 to 1 and NS2. Inner transition metals are known as F block elements. There are two F block elements. One is 4F block, another is 5F block. 4F block elements are known as lanthanide series and 5F blocks are known as the actinoid series. They have incomplete d orbital electronic configuration in their normal state and in their oxidation state. They are generally radioactive. So these are the explanation of the S block, P block, D block and F block. In your syllabus, we have to study S block elements and P block elements. D and F block elements, only few things we have to study. Students, my dear students, up to this today, next day we will go detail for the S and P block elements and various questions on this topic. Okay, good day students.